Welcome to Python Basics with AJD. In this video, we're talking about Python functions. Let's go ahead and see Google Colab so we can learn about Python functions. So I just go ahead and type Colab. I've used it a lot, so it just comes pretty easily. So Python functions is the 17th video we are looking at. As far as Python basics are concerned. Okay, yeah, here it goes. Python functions. First of all, we need to know that a function, okay, I can split this up for easier readability. So I'll just go this way, then push this down and do this. Okay, so a function is a block of organized, reusable code that performs a specific task. As far as Python is concerned, a function is a block of organized, reusable code that performs a specific task. Functions help improve code readability, reduce redundancy, and modularize programs. So the idea of modularity is that you can have, if you have a very large thing to do, and then you can just define a very small part of it. And once that works, you can duplicate it over and over again. So that's one idea. So now, talking about Python functions, the syntax generally is this. So it starts with def. Def is a keyword for defining functions in Python, and then that follows a function name, which is anything you choose. All right. But so this def, it's standard. You cannot change it. Then you have the function name. You want to choose a function name that shows what exactly the function is about. Then you have some parameters you can put to make the function work. And of course, you can have optional doc string explaining the function. Then of course, this is just a comment talking about the body of the function, other things you want done. And then lastly, you have then you return a result, which is optional. It depends on the kind of function you're working with. Okay. So if I run this now, it's not well, it's so that this is me technically defining a function called function underscore name that will require some parameter. It has run, but I didn't tell it to give me any particular result. So that's why it's not giving that. Okay. So like I said, def is the keyword. So a Python keyword is standard and you cannot change it. You cannot use it for a variable name. So just like we said when we're talking about naming variables. So it's keyword to define a function. Then function name is just an identifier for the function, like the name of the function for sure. Then parameter, these are inputs for the function, which is sometimes optional. Then return is the keyword to send output from the function. It is also optional. So we'll go ahead and see how functions can actually work. So first off, I want to talk about defining and calling functions. How do you define a function and how do you call a function? Okay, let me cut this off so I can explain calling a function in a different way. Okay, so to define a function, basically, just like what we saw up there, you just need the keyword def, then a function name and some parameters, which is optional, like you saw. So here now we have a function called greet. And what the function does is to print hello world, basically. So I'm going to use alternate enter to run this so that it can create another cell. So you can see it has run successfully, no error. Then I paste this here. So this is you uh, defining the function. So we have defined the function in the first cell. In the second cell now, we want to call the function. So I just come here. To call the function, all you just need to do is copy this, the function and the space, and this is what we have here. And then by the time you run it, it's automatic. So by the time you now run this one now, it prints hello world as it is expected to do. Okay, let me delete this extra one. Right. This can go. So we call a function using def function name and telling it what to do, and then we define a function like that. Then we call it by copying out the function name and the brackets, and then if there are parameters that you supply here, we don't need parameters now. So next, so we have done function without parameter. Another thing, we can do a function with parameters, right? So imagine instead of just saying function greets. Now, one thing you should know is that as far as this function, there's no other function defined with this name. Even if I go to the end of this in fact, let me even try it. If I copy this now, as far as it is there, even if I've done several other things, and I'll go, I then go to the end of this document, okay? I go to the end of this document and just say greet again. It will just print the same hello world it is always meant to do, right? So, as far as it is not overwritten, it will always work anywhere in the session in the document. Okay. So function with parameters is the next thing we want to look at. Now you discover that when you define a function like this, when you have a keyword like define for, if, and all that, at the end of the line, you have full code. I think we talked about indentation. So you can say indentation coming here. So after this first line, the next line has to be indented. So here, imagine we now want to greet a specific person. So we say define greet person. Okay, again, this is you call it. In fact, let me even delete this one so I can demonstrate the idea of calling a function properly. So I'm declaring a function. I say define a def greet person name. So we want to greet a specific person who will be named. And once the person is named, so what the function will now do is it will print hello and the person's name. So the name has been defined here. So whatever name you supply, so it will say hello, whatever. Okay, so let me run this using alternate enter so it can create a new cell automatically. So that is done. We have a check, no error. So it means the function has been defined. So how do we call the function? So just come here and copy this greet person and the bracket. Okay. So instead of name now, I can just come and give a specific name. So I can now say greet. Okay. Of course, don't forget that a name like that is a character. It's a string. So let's say greet Emmanuel. Okay. I press enter. So it just says hello, Emmanuel. So I can, still go ahead and say same thing. I just paste again and say greet Margaret. Okay. And it just says hello, Margaret. So that's a function with parameter. Okay, now we can also have a function that returns a particular value. So like you can define a simple calculator. You can use a function to define a very simple calculator. Like you just want a function that quickly adds two things. So here now you have define, add. Okay, let me remove this so that you can always see that you can define a function on its own without having to call it in the same cell. So we define a function called, the name of the function is add. And then you see this def will always be there. It's because it's a keyword. So this add can vary depending on what exactly you want to do. So this add now takes two parameters, A and B. So, and what happens when you take these two parameters, A and B, it returns the sum of A and B. So I can even say, okay, let me run this one first, right? And then go on to others. So I use alternate enter to run so that I can just, so if I need to now run or call this function, I just copy the function name and the variables. So here we are dealing with numbers, so we don't have to use string. So maybe I want to add 7 and 17. Okay, I just press enter. So it gives me 24. So because I've told it to return A plus B. So if I come again and say add, say, uh, 18 and minus 25. Okay, 18 and minus 25. It will add, it will say 18 minus 25, right? So another thing we can do is we can actually print. So if I want them to appear separately, I can print. So I can just say print this and close the bracket. Here again, I can print. When I just this second one is overwriting the first one because I didn't say print. So now that I'm saying print, it shows me the two at the same time. So if you want to see the two at the same time, you can go to another cell or you use print to call them. So I was going to talk about, say, maybe A, instead of A plus B. In fact, maybe we even need more than A plus B. Maybe we also need A minus B. You want the addition, the subtraction. You need the so this one is even giving me all these things now. So I can just accept everything. Okay, it's not highlighting well. Okay, let me just type it. I think it's taking time already. So maybe I just want all these things. I want I need the regular division. Maybe I even need the floor division, the integer division, and maybe I also need the modulo division, right? So I can have all of this. So, but don't forget to run the cell again. So I have committed it. So if I come back now, then I can get all these results now. So you see, the first one is 17 plus 7, 24, 17 minus 7, 17 plus 7, 24, right? I mean, 7 plus 17, 24, 7 minus 17 minus 10, 7 times 17, 119, 8 divided by, that 7 divided by 17, you have this 0.411, blah, blah. Then A floor B, that's 7 divided by 17, 17 goes in 7, 0 times, right? And the remainder, so 17 goes in 7, 0 times, and it remains 7. That's what we have here. And for the other one, I have 18 minus 20, 18 plus minus 25, that's 18 minus 25 minus 7. Then 18 minus 25, that's 18 plus 25, that's why you have 43. 18 times 25, you have minus 450. 18 divided by minus 25, you have minus 0.72. 18 floor, this, it's minus 1. 18 remainder minus 7. So you have all of that. So you can actually have a bunch of things to be returned at the same time. So let's talk about function parameters. So far, we've talked about, we declared a function without parameter. Then next, we define a function with parameter. Then we define a function that returns a value, right? So now let's talk about the parameters that we use in functions themselves. Imagine that we have a situation where we have positional arguments. So in this case, arguments are assigned based on their order, right? So you have define, and the name of the function is power. Then you have a base and you have an exponent. So then you return base raised to power exponent. Okay. So automatically anything you type first is the base. Anything you type second is automatically seen as the exponent. So again, this is so without that now. So this is the function define. So define power base exponent. So that's committed because we have this check and there's no error. So you can now bring this now base comma exponent. So okay, let me do alternate enter so it creates a new cell automatically. So so anything you put here, if you say 3, 4, okay, so it sees the first thing as base and it sees the second one as exponent. So if you run that, that gives you 3 raised to power 4, and that is 81. Okay. Now, another thing is that you can also have keyword arguments. So here we have positional arguments, right? You can have keyword arguments. So in that case now, you can call the function and then change. So, if you don't specify base or exponent, the first one is seen as base, the second one is seen as exponent. But in this case, imagine keyword exponents now. So for the same power function now, you now say print power, exponent is equal to 3, base is equal to 2. So you see, exponent is coming first, base is coming second. Whereas if you don't specify, base is automatically coming first. So in this case now, we can just say exponent 3, 2, that's 3 raised to power 2, that would be 8. So if I also bring this one, okay, so it means you can actually reverse the order as far as you specify what the base is and what the exponent is. It doesn't matter which one comes first in that regard. So this one now, 3 raised to power 2 is going to be 9, all right? And 2 raised to power 7, I think that's going to be 128, right? So if you run that, 2 raised to power 7, okay, yes, I get it. So this is 2 raised to power 3, this would be 8 for sure. So you see, I was following the base exponent thing. So, but now because I've specified that base is this and exponent is that, so 7 raised to power 2, this is 49 as we have here. So if you don't want to mention the parameters, you can any number you pick, it will just go normally. But here, if you want, you can change, you can scatter the order and just as far as you specify what the parameter is, it will still follow the regular thing, though the order is not the same. So arguments are assigned based on the parameter name. So you can assign arguments based on parameter names. Then we have the possibility of having default arguments, right? We can have default arguments. Imagine that you define a function called greet, name equals guest. So by saying, you could say the other time we just said only name. So greet name, and you mention a name and it will greet the person. Now, what if you just have greet name equals guest, and then it will print hello name. So it means if you don't specify a particular name, it means it is going to print hello guest, right? So I run this to define the function. Let me use alternate enter. And then how do you do this? Then you just bring greet and this whole thing. So if you bring it down here, all right, and you delete all this. So if you don't mention a specific name, guest is already seen as a default argument. So if you run this, it is going to say hello guest. But if you don't want hello guest, right, then you can then let me use alternate enter again so I can create a new cell automatically. So if you now say great, and then you now uh say Mr. President, right? Great Mr. President. So now it overrides the guest, right? So if you don't specify a name, so if you have declared, so this guest here is seen as a default argument. So if you don't supply any argument, so that will be taken by default. So it's more like you're creating a baseline. Worst case scenario, we use a generic name and say great guest. So you could actually go ahead and also say greet a specific person, right? Say you want to greet Olawale, right? Great Olawale, like that. So that goes. So then you can have variable length arguments. So in this case, you can have args for non-keyword variable arguments, and you can have quarks for keyword. So you see KW talks about keywords for keyword variable arguments. So look at this case now. You have define sum all args. Sum all star args means whatever exactly is happening, you are returning the sum of every kind of number you supply. So in this case now, you have define sum all args, return sum of every argument you supply. So you can have like 1 million arguments. So it will automatically just sum because that's what you're doing there. So if you print this now, if you run this, of course, so in this case, I call the function and I run it at the same time, right? So sum add 1 plus 2, 3, 3 plus 3, 6 plus 4, 10. All right. So if I use alternate enter and create a new cell, for instance, I can just say print, okay, sum all, print sum all, then I do this. Then I have like okay, let me even try this. 1 to 7. Does it work? Okay, this doesn't work. Good. I just wanted to try. So you have, say, everything you supply, 3, 5. Okay, let me say 1, 3, 5, 7, 9, 11. So there's a rule like this that when you add the first n odd numbers to give you the perfect square, this is 1, 2, 3, 4, 5, 6. So when you add the first 6 odd numbers, it gives you 6 raised to power 2. And that's why we get okay, sum underscore all. You can see variable name is the problem there. So it was even underlined. So that will give you 36 like that. So if you add the seventh one, which is 13, you're going to get 39. I'll be 49 like that. Okay. So here, this one is everything that comes, you're summing up every variable. That's what args does. And then here we talk about keyword arguments, right? So when we talk about keyword arguments, you're supplying keywords here. So imagine define print info double star. So you see, args has 1 star. So keyword argument has double star, right? So define print info star star keyword argument. So yeah, that's KWARGS quarks. So for key and value, so now you need keywords, right? So for key and value in quarks.items, whatever items you end up supplying, then you can now print whatever the keys and whatever the values. So in this case, now say print info, name is Alice, age is 25. So you can now supply any set of key values, right? So you can run this line. So it gives you name as Alice and age as 25. So you are printing all that. Now, what if we extend it? So this one can be extended to as many values as possible, right? So okay, let me come now and run this, alternate enter again. So I put this. So instead of print underscore info, name is Alice and age is 25. Let me now say country. Okay, country is Nigeria. Country is Nigeria, and age, or let me even say tribe or ethnicity. Let me say ethnicity. I think I prefer ethnicity. Ethnicity is equal to, say, Ogu, right? OGU. So if I run that, so country, Nigeria, ethnicity, Ogu. So it prints that like that. So we can use variable length argument. So in that case, you can supply as many variables as you want, right? So now, of course, in the next, okay, after this video, we'll talk about advanced functions, but after that, we'll be talking about variable scopes in Python, which is more elaborate, but just to let us know, there are variable scopes in Python. We can have local variables and global variables. Local variables are defined inside a function, and it is not accessible outside of that function. Okay? Then global variables are defined outside functions and they are accessible everywhere. For instance, if I say x is equal to 10, so it's a global variable because it is defined not within a particular function. So if I now define a function, I say define a function called example where y is 5. So what this y is 5, which is defined within this function as a local variable. But then I can access this x that was defined outside the function inside the function. So y is 5 local variable. Then I say print inside function x comma y. So it is going to print this x that was declared and then this y that's the declared globally and y declared locally. So in that case now, you just say example. So it's, and then we say print outside function. So um let's do the first one. So normally to print this now, you just say example this, and it doesn't require parameters because it knows the job is to print x and y. X is global, so it can be accessed here. Y is local, it can also be accessed. So we run this and it just prints 10, 5, right? So okay, alternate enter to print the next set. So what if I now say print outside function? So inside this function now you can see I now want to print outside function, then I say comma x, right? So in this case now, so I print y, this is going to give us an error. Oh, okay, this prints, okay, no, this prints the outside function because it is accessible everywhere. But I think what I really want to do is this. What if I just come and say example, okay, and I say, so in the example, I just say, um, so if I run this, okay, it still prints the 10 5. Okay, I think that works. Okay, for this now, print outside function x, it's still accessible. But what about printing y? If you want to print y outside the function, that won't work. Let me just bring this now. Alternate enter. Then imagine if I want to print y now, let me uncomment this. Oh, okay, this is print y. So imagine if I print y now, it's not going to be accessible because y is not known outside of the function that was defined. So y is local to the function example. So if I want to call y, I have to be calling it inside of that local function, right? So that's how that works. Okay. So name y is not defined. So it is defined within the function, but not outside of it. So you can only call y within the function. Okay. Okay, let me try that and see. Print, okay, then print example, then I have y. Let's see what happens. Okay, y is not defined. So because that's not the way to call it, right? So we go on to for talking about global keyword now. Now, if you want to make a keyword, if you want to make a variable still global, you want to define it within a function and then make it global, it is still possible. So in that case, you can say define modify global. So global x. So though you define x within the function, right? So if you say, well, as far as you use the keyword global before it, it can be accessed. Okay, because we have x. Okay, well, our x before, was our x before was 10. Okay, but let me use a totally different function so that you can get the gist. So if I define z within, we are defining within the function. Normally, it's supposed to be a local variable, but because we use the keyword global before it, it is going to be global actually. So in this case now we now have z. So define global z plus equals 5. Plus equals like we said under arithmetic operations, right? It means whatever z was. Okay. Okay, I think let me use the x like that. So x already was 10, right? So if we do this now, it's going to give us 15 because that's going to be 10 plus equals 15, and then the new value of x is now 15. So in this case now, we can, because we have used the keyword global, we can just we can call the function modify global, and we get so we get, okay, this one has been called, right? So alternate enter now, and then we can actually print x, and it's okay because I've done it more than once now. That's why it's giving us 20, right? So because anytime you run it, it's going to add 5. to the function like that. So this function, you can call it both within X and outside of X. So I think, did I have to print this? I don't think so. Print modify global. Let's see what happens with this. Yeah, so it doesn't print anything. So we don't need to print, right? Okay. And then we can just then, so because X has been defined as global here, so we can have it outside the function. So by using the global keyword, so but there's going to be a video dedicated totally to variable scopes. Let's watch out for that. Okay. So we have lambda functions, which are also known as anonymous functions. So these are small one-line functions without a name. So you don't need to, for lambda function, you don't need to give them a special name. For instance, maybe you are working on and you just want to do a quick calculation, quick like that, just say, so like you want to square any number, so you say square is equal to lambda. Once you start with lambda and then you define the variable does not have to be x, it can be anything. So now say lambda x is x raised to power 2. You know, start is power 2. So then you can now print square. Then you supply 5. So it means that your value of x is 5. So you have, so you run that and you can get 25. Okay, that's why you have this now. So imagine you can also have multiple arguments. Say multiply. So you want to multiply two numbers. So you just say lambda a comma b full colon a star b. So it means any two numbers I supply, multiply them together. So I just have print multiply 2 times 4, and the answer is 8. So those are lambda functions. So they are quick functions in one line that you can use in case, like it's more like you are quickly doing something and then you just want to find a result and keep moving. Okay. Then you can have higher order functions too. So functions can take other functions as arguments or return functions. So if it's more like in mathematics, this is what we call function of a function, right? Like you have um, x is equal to, you have y is equal to x squared, and you have y is equal to square root of x. So function of a function. So you can now say function of f of g of x. So that will now be square root of g of x, and all of that goes in. So here now you say you have a function, you define the function as apply function f, whatever f is, then you have a value. So then you return f evaluated at that value. So for instance, so you have that, right? Then so you have a function f like this. Then you now define another function cube x, which returns x raised to power 3. So if you now print this apply function, right? Cube. So this cubes the number. So this is the function this f now stands at the function. Then it means that it's going to give you the cube of this number you supply here. That's why at the end of the day, you're going to have 3 raised to power 3. So it's like function of a function like that. Okay. Then we can also have recursion. A very good example of recursion is factorial, right? Factorial is if you have 5 factorial, that's 5 times 4 times 3 times 2 times 1. So you have that repetition going on like that. So a recursion, if it's a function that can call itself, and it is useful for problems like factorial and Fibonacci. So these are very good examples of recursion. For instance, if you define the factorial function n, so if n is equal to 0, you return 1, because at the end of the day, when n is 0, you return 1. Else, if n is not equal to 0, you go to n, you have n star factorial n minus 1. So it keeps going like that. For instance, if you are looking for the factorial of 5, so it comes and says, oh, is n equal to 0? The answer is no, right? So since n is not equal to 0, it will not return 1, it will go to else. So it means to now say 5 times factorial of 4. So you already have 5. So factorial of 4, it goes again. Is n 0? No. So it now goes 5 times factorial of 4 now will now be 4 times factorial of 3. It goes again. So that's why you have 5 times 3, 5 times 4 times 3 times 2. Then by the time times 1, by the time n now becomes 0, it comes, is n is equal to 0, 0. So it's more like you're having 5 times 4 times 3 times 2 times 1, because n is now 0 times another 1. So at the end of the day, you have all of that, and that is 120. Of course, you can still run it, with other values, because the function is already defined. So imagine I can just come, alternate enter, okay, because I want another cell. So I just say factorial, say 15, that's a lot. So it gives us that very large number, okay? Then we can also have doc strings and annotations. So doc strings are multi-line string explaining a function, right? And annotations are optional type hints. For instance, you want to define, you're defining you define the function add numbers. So A is integer, B is also integer, and it ends up giving you integer. And then the story is this adds two numbers and returns the sum. So and at the end of the day, return A plus B. So in this case, now you now say help add number. So because of the docky string you have used here now, so it helps. So help add numbers tells you, it now shows you the docky string, which is to add two numbers and returns that. So here now you see help on function, add numbers in module main, add numbers, integer and integer, it gives you integer. So add two numbers and returns the sum. So that is one way to go. But of course, because the function is also returning A plus B, you could actually still call, you could actually call the function, all right, by supplying value. So if you come here now, we said it should return A plus B. So I just come and say, just make sure they are integer. So I have 10 and say 33 or 32, then it returns 42. So it can return. So but the docker string part is to tell us that it's going to return the values. I mean, so the docker string tells us what it is going to do, basically, and then it can still go ahead and do the actual thing. Okay. So another thing we need to know is that there are built-in Python functions. So Python provides many built-in functions like length, sum, max, min, sorted, etc. For instance, if you have numbers 31415, so if you want to know the length of the numbers, right, what that just does for you, it's like it tells you how many numbers you have there. So numbers 3141415. So print length numbers. I use Alt Enter, so it creates so you see it tells us we have 5 numbers. So we go for the next one. So we want to print the sum of all these numbers, right? So to print the sum of all these numbers, this is 3 plus 1, 4, 4 plus 4, 8, 8 plus 1, 9 plus 4, 14. So print sum of all the numbers, you get 14 right there. Alt Enter, I create a new space, a new cell rather. So again, want to know the minimum of all the numbers. Of course, we have the smallest number there is 1. So print minimum, we have 1. Okay, Alt Enter. Then what about the maximum? The maximum number there is 5. Print maximum, we have 5. Then lastly, do you want to sort the numbers in order? So, the numbers are scattered 31415. So, yeah, by the time it's sorted, you can see the results as 11345, like that. Okay. So, imagine that. Let me add some random numbers like that. Let me just say 45, 21, 0, minus 5. So I'll run it all over again. So I run it, tells me the length is 9 numbers. Then what is the sum of all the numbers? It gives us that by the time we sum it all up, it's 14. Oh, is it still 14? It shouldn't be 14 anymore. I've not run it. Yeah, it's now 75. What is the minimum? That has to be minus 5 because minus 5 is small. Okay. Okay. Has that been run? So yeah, that's minus 5 now. Okay. So now we have the maximum. Of course, the maximum is the biggest number now, which is 45 for sure. And then we have print sorted number. So we can now sort the numbers like this. So, all this. So it sorts it from -5, 0, 1, 1, 3, 4, 5, 21, 45. But let's go back to what we had before. So, you can have as many numbers as possible, and that's good. Okay, so we have our 5 back as the length. We have the sum as 14. We have the minimum as 1. We have the maximum as 5. And then we have the sorting as 1, 1, 3, 4, 5. So there are some practical examples we can do. For instance, if you want to check a prime number, how do you check a prime number? A prime number is a number that has only two factors, itself and 1, right? So you want to define a function. Define is prime if n is less than or equal to 1, right? Return false. So if n is less than or equal to 1, return false because 0 and negative numbers would, okay. If n is less than or equal to 1, you return false because any number less than or equal to 1, okay, this is false. So we now say for I in range 2, integer n star star 0.5, that's n raised by half plus 1. If n, the modulus division, it gives zero, then you return false. So that way, so by the time we go through this process, the number we would have known if the number is prime or not. So the question is 17. So we now call the function is prime 17, you know. Um, so let me just run that here. Press enter, alternate enter. So it creates a new cell. So we copy this. So this was asking, is 17 a prime number? And then the answer is correct. It is true. Then if we do this and say, I bring this again. Okay, let me just copy the print now. Oh, can I think, shouldn't it work? Okay, now the function of this one is it's not printing immediately. So, or I think it should work still. Let me see. So for instance, 10 is not prime. So if I do is prime 10, it should be false. Yeah, that's false, right? So we don't have to have print actually, because we already said told you what to do. So, but this whole algorithm here is how to check for prime numbers right there. Okay, so another example, we can have Fibonacci series. So imagine the idea of Fibonacci is you start with two numbers, 0 and 1, and then you add these two numbers, two consecutive numbers to get the next one. So you have 0 and 1. Okay, normally the whole idea of Fibonacci is, yeah, so you have 0, you have 0, you have 1. Next will be 0 plus 1, that's 1. Next is 1 plus 1, you have 2. Next is 1 plus 2, you have 3. 2 plus 3, you have 5. 3 plus 5, you have 8. 5 plus 8, you have 13. And it goes on like that. All right. So that's the idea of Fibonacci. So, and the algorithm to get that is this: you define Fibonacci, and it takes parameter n. So tell the number of figures you want to have in that sequence. So in our fib series, you start with 0, 1. That's like initialization. That's the beginning. So you now say for I in range 2 to n. So because you already have 0 and 1, so starting from 2 to whatever n you choose, then you now have the Fibonacci series dot append. So you have 0, 1, right? So to now append the fifth series minus 1. Minus 1 will be this one. Fifth series minus 2, that will be 0. So this append will add the next number to you. So if you say fifth series 10 now, so it will add it will keep adding until you get to until you stop at a step less than that 10, right? So Fibonacci for up to 10 will just be 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, like that. So imagine you want Fibonacci for up to 20. Okay. So, or let me say even 15. Okay, let me say, yeah, let's say 15. So, you just have all of that. You keep going. So keep adding. So 21 plus 34, that's 55. 34 plus 55, 89, and so on until you get to the end. So how about using functions with map, filter, and reduce? All right. So here you have, in this case now, you need func tools. So for func tools, you import reduce, because that's where the reduce comes from. So you now say numbers 1, 2, 3, 4, 5. So map, you want to square each number. So you have squares. So you list map, lambda, all the square of all these numbers. Then you filter even numbers. So you want all the even numbers. So in this case now you have evens. So you use list again. So you use list to start. Then you filter from 1, 2, 3, 4, 5, what are the even numbers? And use a lambda function to do the filtering. So x, the modulus is 0. So of course, any number, when you divide by 2 and you get, you do modulo and the remainder is 0. Of course, that's even. If the modular is not 0, that is odd, as you can see in line 11 and in line 12. Then of course, you want now the total. So lambda, you have x comma y, x plus y, and then the numbers like that. So at the end of the day, if you run all this now, so you just print squares, evens, odds, and total. So first of all, you have the square. So square of all these numbers. So 1, 4, 9, 16, 25. Then what about the even numbers? That's 2, 4. The odd numbers 1, 3, 5. And of course, the sum of all the numbers, you add the total of all the numbers like that. So, I mean, so far we're talking about functions and some key takeaways from here. Functions improve modularity and reusability. So you can write small functions and then you build a whole code out of that. Then Python supports positional keyword, default and variable length argument like we've seen already. Functions can return values, other functions, or no value at all. All right. Scope and lifetime of variables matter, local versus global. Anonymous functions like Lambda are useful for small operations. Then recursion provides elegant solutions for repetitive problems, and always use doc strings to document functions. So if you're writing your own function, I think along the line we'll be talking about Python libraries, modules, packages, and things like that. So you'll understand. You may even get to a point where you write your own function or library for Python. So in that case, you need doc strings to actually tell us what those functions would be doing. So this will come to the end of this video. Interesting, I wanted to join this and the next one, but I mean, this is so long that if I had joined that, it's going to be a very long one, thankfully. So we're looking at advanced Python functions in the next video. Let me know how helpful this video is for you. And if there's something you'd like me to try out, feel free to let me know. If you have subscribed already, thank you so much. If you haven't, please go ahead and subscribe and hit the notification bell so you can always get alerted each time a new video is released. You can take it a step further by clicking on join to become a member of the channel. You see some special privileges you stand to gain by being a member of the channel, actually. Ultimately, don't forget to like, share, subscribe so that more people can have access to the great content I have going on here. Till I come your way again, keep doing Python right. Bye.